This lesson will be on an introduction to the measurements and calculations used in chemistry. This video will be going over these topics. There are timestamps in the description box below if you would like to skip to a specific topic. So a measurement determines the magnitude or capacity of something, and this is represented by a set standard unit. So for example, the standard unit could be miles or kilometers, inches, Celsius, yards, and so on. And we can describe our observations as either qualitative or quantitative. So qualitative is where you describe something. So it's not a number. For example, we have two examples here, and it is describing qualities of our liquid and our metal. So our metal is smooth and shiny and our liquid is clear. So clear, smooth, and shiny will be qualitative observations. So descriptive observations. And then we have quantitative, and quantitative is where numbers are observed. Here we have mass, weight, volume, and density, and there is a difference between the four. So mass measures how much matter is in an object, so how heavy something is. Weight, on the other hand, is measured by how much gravity has an effect on an object. And then we have volume, which measures how big something is. And lastly, there is density. And density is a property of matter, which represents the mass per unit volume. And you can find this by dividing the mass by the volume. The need for common units was made to ensure that confusion and chaos would not happen. Unfortunately, although standard systems of units were established, different systems were adopted in different parts of the world. For example, there was a situation where a plane used the wrong system of measurement when calculating how much fuel was required, and the plane ended up with only half as much fuel since pounds was used instead of kilograms. So when the fuel ran out halfway through the flight, the pilot had to make an emergency landing. Therefore, it is important to have an international system. The most widely used system is the metric system, and only 3 countries don't use the metric system, and that includes the United States, Liberia, and Myanmar. Therefore, the SI system was created, and this is known as the international system, and many scientists use this system to make their measurements. The SI system is similar to, but not exactly the same as the metric system. For example, in the metric system for temperature, we would use Celsius. However, in the SI system, we would use Kelvin to measure temperature. And here we can see a table of the 7 different things that we can measure easily using the SI system. So the first one is length, which is how long something is. The unit for that is going to be a meter. Then we have the mass of something, which is how much matter something has, and that is going to be measured in kilograms. This is one place where it differs slightly from the metric system, where you would just have grams in the metric system as your basic unit, but here for the SI system it's going to be kg. Then there's time, so how long something is taking, and we're going to use seconds. Temperature, which is related to the average kinetic energy or the heat that something has, will be using kelvins. Then the one that's really important for chemists is the amount of something, so that would be the mole. And the last two, you're really not going to see too much except for maybe in the electrochemistry part of chemistry. So the electric current is measured in amps or amperes, and luminous intensity is measured in candelas. Another thing to worry about is when you are reporting these units, and the numbers associated with scientific measurements are often very large or very small. For example, imagine the distance from the Earth and the Sun. So the distance from the Earth and the Sun is approximately 150 million kilometers, and written out this number is rather bulky. Therefore, in scientific notation, it makes a very large number or a very small number much more compact and easier to write out. So to find the scientific notation, you would go to the very end of your number that you are given, and you would insert a period or a dot or whatever you want to call it. So you would insert this period at the very end of the number, and the numbers that aren't zeros, you want to make sure that it is closest to the smallest number you can make it. So we have 1 and 5 here, and you want to make sure that the period is between the 1 and the 5. So we're going to go to the left 1, 2, 3, 4, 5, 6, 7, 8 to the right. And therefore we're going to end up with 1.5. And since we went 8 to the right, that's going to be a positive exponent, and it's going to be 10 to the 8th power. So we're going to have 1.5 times 10 to the 8th power. So if you would like this to be better explained, you can check out a video on the channel that has more practice problems. So to sum up how to get scientific notation, the exponent is equal to the number of places you move the decimal. And if you move the decimal to the right, the exponent will be negative. If you move the decimal to the left, the exponent will be positive. If you would like some more practice problems again on how to write scientific notations, you can check out the video on scientific notation practice on the channel. Here we have a unit prefix chart. This is something useful to know or memorize. To know what each symbol, notation, or prefix means, when I was taking chemistry, my instructor made us memorize this chart so that we knew the prefixes to the scientific notation. And this chart will be extremely helpful whenever you need to make really small or really large scientific calculations, or even when you're measuring things in beakers. We can measure closeness by a variety of statistical methods. This can be either by the mean, the median, the mode, the standard deviation, or other methods. And when we talk about accuracy versus precision, well, accuracy is when we measure how close the values are to the true or to the accepted value, whereas precision is measured by consistency. So let's take a look at some examples here. For the first one, it is both accurate and precise. These dots are close to both the bullseye and one another, so they are both accurate and precise. For the second one, these dots are close to one another, which shows consistency, but they are not on target, so they are only precise but not accurate. And for the last example, these dots are neither on target nor are they close to one another. Therefore, they are neither accurate nor are they precise. So as far as significant figures go, they're important because we live in the real world and not in a theoretical one. So we need to report only the important values, or the significant ones. And there are 5 rules when determining significant figures. So we can consider non-zero numbers to always count as significant figures. And these are going to be your numbers or your values that are 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So for example, we have 1975, and this has 4 significant figures because 1, 9, 7, and 5 are non-zero integers. The next rule, we have leading zeros. And leading zeros do not count as significant figures. So for example, we have this number here, and there are only 2 significant figures because the zeros before the 2 and the 5 are considered to be leading zeros. The next rule we have is captive zeros. So these are any zeros that are in between two non-zero integers, and these zeros always count. For example, we have 1.009. This would have 4 significant figures. And we have the rule of the trailing zero. And for trailing zeros, it depends whether it is important or not. And it depends mostly where the decimal is placed. For example, if we have 100, this would have only one significant figure. However, if we have 100 with a decimal at the end, this would have 3 significant figures. And lastly, we have the exact numbers. And with exact numbers, it means that these numbers were not obtained using measuring devices, but were determined by counting. So for example, if you have 5 experiments, 10 lemons, 2 molecules, this would have an unlimited number of significant figures, no matter what. If you would like more practice problems on significant figures, there are a few videos on the channel which you can check out. And here are a few more rules when calculating significant figures in terms of rounding, addition, subtraction, multiplication, and division. So for addition and subtraction, make sure to use the number with the least number of significant figures. The same can be pretty much applied to multiplication and division as well. And in terms of rounding, make sure to round only during the very last step of your multi-step calculation. Chemistry often involves converting one unit to another, and this is known as dimensional analysis. And when it comes to dimensional analysis, you can follow a 5-step plan to make it easier to convert from one unit to another. So the first step is to read what is being asked of you. The next step is to reread and to identify any important values. Next up, you will want to plan out and set up your conversion. So what equation is needed to convert from one unit to the other one. And then we will calculate our answer using dimensional analysis, which is just canceling all the units except the units that are needed in the answer. And then for the last step, you are going to want to double check your answer and see if it makes sense. So here on the right side, we have an example of what a dimensional analysis setup will look like. So let's look at a few examples for significant figures and dimensional analysis. We have here a dimensional analysis problem to solve. First, let's read the problem and figure out what is being asked of us. So we want to figure out how many seconds there are in one day. So that means our final answer needs to be seconds per day. Any other values we will have to cross out. Now we want to set up our plan or our dimensional analysis equation. So we need to figure out how many hours there are in a day. So we know that there are 24 hours in one day. Next up, we want to be able to cancel out our hours, so we need to figure out how many minutes there are in an hour. So we know that there are 60 minutes in 1 hour. And then we want to cross off our minutes, therefore we need to figure out how many seconds there are in a minute. So we know that there are 60 seconds in 1 minute. And now we just have to cross off what we don't need. So we just have to leave seconds and days. So we don't need the hours and we don't need the minutes. So now we are only left with the day and the seconds. So we know that we have set up our dimensional analysis correctly because it's going to be seconds on top and days on the bottom, so seconds per day. Now all we have to do is calculate. So we're going to do 24 times 60 times 60 over 1 times 1 times 1. And we end up getting 86,400 over 1. Therefore, we get 86,400 seconds per 1 day. Let's look at another example in terms of significant figures. So for this one, it's asking us to round 250,791 to 4 significant figures. So let's write out our number here, 250,791. So we want to start from the leftmost side and count from 1, 2, 3, 4 significant figures. So we have 1, 2, 3, 4. Now it's asking us to round, therefore rounding rules apply, and since 9 is telling us to round up, therefore the 7 will be rounded to an 8. So for this value to be rounded to 4 significant figures, we will ultimately end up with 250,800. And this is considered to be 4 significant figures because the 2, the 5, the 0, and the 8 are all significant, but these are considered to be trailing zeros, so they are not significant. This 0 in between is a captive 0, and it is considered to be significant according to the sig fig rules. If you enjoyed this content, please consider subscribing to help support the making of more videos. Thank you and see you in the next video.